Hassler here. All right, so we're going to be taking some notes on the 5-6 vocabulary. These are just review ideas. Nothing in here is really all that new, other than the idea of determining if something is linear versus not linear. And it's not really that new because we're just using slope to figure that answer out. And we've used slope before. So the first thing I want to talk about is this idea of being linear versus nonlinear. So linear is the word line plus the AR versus nonlinear, which is the same as saying not linear. My A, for some reason, does not want to get made. Sorry about that. Not linear. I'm going to draw this line down here. Okay. Linear means the slope is the same between any 2 points. I apologize. For some reason, right in this area here, my marker does not want to work. All right. Slope is the same between any 2 points. The slope is the same between any 2 points. Versus nonlinear would mean that the slope is not the same between any 2 points. Slope is not the same between any 2 points. I think a good idea is to take a look at a picture. So to be linear means that I just have a straight line, and I can pick any 2 points on this straight line and find the slope between any of those 2 points, and I would get the same slope calculation. So if you watch the 5-6 lesson, we were looking at volume of an IV bag, and we found the slope between 3 sets of ordered pairs, and it was the same no matter which set of ordered pairs we used. Versus something that's nonlinear would be something like this. Yeah, these are 2 lines, but if I found the slope between these 2 points, I would get a different answer than the slope between the second point and a point here. And so for that reason, this would be nonlinear. I do not get the same slope between different sets of points. And so one of the things that we reviewed was just slope in general, right? So to find slope, slope is a rate. Or a slope, we're comparing 2 units. To find that slope, we're going to do change in y, delta y, over change in x, delta x. I'm going to write that a little bit differently. Before we had talked about y2 minus y1 over x2 minus x1, but now we're using this function notation, so I'm going to write it with this function notation. F of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. And remember that this notation, this f of x sub 2 is just the same as saying y sub 2, and f of x sub 1 is the same as saying y sub 1. That just means that I'm finding the output at the second x coordinate and the output at the first x coordinate. The other thing that we need to remember is the equation of a line is that y equals mx plus b. M is my slope. B is my y-intercept. A y-intercept is when the x is 0, so 0 comma blank, or x is always 0. The other thing that we can recall then if we're talking about a y-intercept is an x-intercept. And an x-intercept is when the y is always 0, so you have blank comma 0, or the y is always 0. So it's going to pop up at you quite a bit. So one of the things we did is we looked at these examples. It says determine if the table represents a linear or nonlinear function. So we have to make that choice. In order to make that choice, we have to find a consistent change in y. So that's what, negative 15 over change in x. 2. So negative 15 over 2 is negative 7.5. And I'm going to check this next set. This is what, minus 30 over 4. And negative 30 over 4 is also negative 7.5. So yeah, table A I'm going to write is linear. Okay. Table B, let's go check table B. Table B has a change in y of what, 15 over 3. And so 15 over 3 is 5. And then we have a change in y of, what is that, 84 over 6. And 84 over 6 is 14. Those are not the same rates, not the same slopes between the 2 points, 2 sets of points, I should say. So that would be a nonlinear function. So now my job is to write the function for the function that is linear, which is the A table, write an equation. And so again, my job is to write an equation in that y equals mx plus b. Only it was f function. So I'm going to say f of x equals, and I need my mx plus b. So remember that m is my slope. We actually calculated that slope. It was the same between all sets of points, negative 7.5. Now I need my y-intercept. So this is where I have to work backwards, right? I have to go backwards till I get an x value of 0. So I have to go backwards 2 spots. And if I'm going backwards 2 spots, I need to go backwards, so add 7.5. I'm going to add 7.5 twice. So I'm going to add 15. 50 plus 15 is 65. Right? So again, I have to go back 2 spots. And I'm going to do the opposite. I'm going to take a positive 7.5. Since I'm going to be working backwards, I'm going to add the 7.5. I'm going to take this number and I'm going to add it to the number that was already the output at 2. And so that's how I'm getting that 65. Find the x-intercept of the function in part C. So just a reminder, the x-intercept occurs when the output is 0. So I need to replace this output with 0. And now I'm going to solve for x. So I'm going to subtract 65 from both sides. I'm going to divide both sides by negative 7.5. And when I do that, I get 8.6 repeating. So you can either write it as 8.6 with the bar. You can write it as 8.67. Either of those two things is okay. What that means is I have the ordered pair 8.67 comma 0. That would be my x-intercept. Okay, so your job is going to be to work on the 5.6 practice. If you have questions, let me know.